Welcome to the Ventura County Astronomical Society's General Meeting. My name is Reza, and I'm the Vice President of Orange County Astronomers, reporting live to you from the Mission Control Group. OCA is happy to join forces with VCAS to make this event happen. Before we start the main talk, I would like to point out to you the ways in which you can interact with us. First is the raise hand function. And find the raise hand button and click on it. This is how we're going to applaud our speaker shortly. Okay, thank you very much. Second, look for the chat menu item. This is how you can send us any comments you may have. And third and last, please find the Q&A option on your screen and look for the Ask a Question button. This is where you can ask our speaker questions during and after this presentation. With this, I'm handing it over to Keith to introduce tonight's speaker. Keith.
Sorry for the delay there. I forgot to unmute myself. I'm Keith Salvis, President of the Ventura County Astronomical Society. Reza, thank you very much. It is a pleasure to have you all here from the Orange County Astronomers and Ventura County Astronomical Society. Let me start with a couple of announcements. Oh, and by the way, I'm coming from Planet Green Screen right now since my actual picture function, for some reason, isn't working. My computer is doing some updates. Couple of announcements. First of all, Ventura County Astronomical Society brings astronomy to everyone. We have a strong non-discrimination policy. We do not discriminate. We're here about astronomy. You come as you are, ready to enjoy what we have to offer. Secondly, we also have a very strong privacy policy. When we do ask you for your contact information, such as your email address, we use it only for internal purposes only. And if we do share it, we'll share it only with, if you opt in. One of those places that we often share our information with is the Astronomical League. And that brings us to Chuck Allen, who is our speaker tonight. And Chuck Allen is from the Astronomical League. So let me read to you his introduction, if you don't mind. Now, Chuck, Charles Allen, we get to call him Chuck, has been an amateur astronomer since age 7. And he actually started giving public programs when he was 12. Now, currently, he's the vice president of the Astronomical League. He founded the league's National Young Astronomer Award in 1991, received the G.R. Wright Award for Service in 1998, holds the league's Master Outreach Award with over 500 presentations logged. I guess tonight we're 501, and is the league's Master Observer with 37 programs completed. If you know anything about the Astronomical League, they have programs where you can get certificates in different observing techniques that make you a much better astronomer and really enhance the enjoyment of astronomy. It isn't just getting out and looking at a telescope, and it isn't just buying an expensive telescope. You can get a lot done with an inexpensive telescope or even a cheap pair of binoculars. And the Astronomical League can teach you how to do that through one of many of their programs. But let me get back. Chuck is the past president of the Louisville Astronomical Society from 1991 to 94, and current program director of the Evansville Astronomical Society. He also served as lead judge in Earth and Science for the Intel International Science and Engineering Fair from 1995 to 2001. He also graduated from Duke University in 1970, served as a U.S. Air Force officer. Chuck, thank you for your service. And graduated from the University of Kentucky College Law in 1997, where he was in one of Kentucky's largest law firms for over 27 years. But Chuck isn't going to talk to us tonight about law. He's going to talk to us about astronomy. Not just astronomy, extreme astronomy, the biggest, the baddest, the hottest, the fastest, the slowest. Chuck, I'll let you take it from here.
Well, Keith, thank you, and Riza, thank you very much, and to all of you in the Ventura County Astronomical Society and the Orange County astronomers. It's really a pleasure to be in California again. I've visited your state 12 times in my life, and I've never had a bad time there, so I'm glad to be back. And I want to thank you for the invitation to speak to you tonight, and I think you'll find this program pretty easy listening and fairly unique in a way. So let's just get to it. And I'll share a screen here. Okay, there we go. I think we're in good shape. So as Keith mentioned, we're going to be looking at some extremes tonight and some firsts, and it will involve astronomy and space travel both. Some of these you're familiar with, and many of them I think perhaps you may not be familiar with. Let's start with the coldest place in the universe ever. The coldest known place that has ever existed in the universe. And oddly enough, this program is going to kind of move from close in to far out. So this very cold place is very close by indeed. Not so close for you perhaps, but it's at MIT. And in 2015, Wolfgang Ketterly's team there used lasers to drain energy from sodium and potassium atoms to produce a Bose-Einstein condensate that reached to within 1/500 billionth of a degree Kelvin of absolute zero. No known place in the universe has achieved that temperature before. All of you know the largest refractor in the world, Yerkes Observatory with its 40-inch doublet. The doublet weighs 485 pounds. The instrument is an F-19. The tube is 60 feet long. It's really quite an instrument, and I'm glad Yerkes has been saved from the wrecking ball. It was a little dicey there for a couple of years. When you start talking about the largest telescope in the world, things get very complicated. They get complicated because of linked telescopes, such as the Keck telescopes that you see in the upper middle right here. Two large mirrors. We have some proposed very large telescopes over here, so we can eliminate those. But currently, if we apply a standard to this question, that is to say that in order to qualify as a given aperture in the list of largest telescopes, that the mirrors have to be on the same mount and can form a single image. And in that case, the winner is the Large Binocular Telescope at Mount Graham. This is a pair of twin 330-inch mirrors compared to Palomar's 200-inch, and has a total effective aperture of 465 inches. They are on the same mounting, they move in sync, and the images are combined. Soon, however, by we think 2025, the extremely large telescope in Chile will replace this with a 1,547-inch mirror. It's 129 feet across. Well, what about the hottest place in the universe ever? The hottest place in the universe ever is some place that occurred at the Large Hadron Collider on the border between France and Switzerland. There, lead ions were propelled to 99% the speed of light and created in collision a quark-gluon plasma that reached a temperature of 9.9 trillion degrees Fahrenheit. That's 5,500 times hotter than the core of a supernova. By the way, I was interested in talking with my friend Richard Gott, an astrophysicist at Princeton. He advised me that once upon a time, an individual actually accidentally stuck his head into a collider and was struck by a proton beam in the head. This was Anatoly Bogorsky at the U-70 collider in the Soviet Union in 1978. He received a 76 billion electron burst of protons through his head and is still alive today. Half of his face is paralyzed. He still has occasional seizures and he's deaf in one ear. And oddly enough, one half of his face looks younger than the other as a result of it, but he's gone on to a very productive career as a physicist. The worst space-related disaster was the Netherland catastrophe. It involved this rocket, the R-16, during a leak repair at the Baikonur Cosmodrome in 1960. And many people think that this was an event that really put the Soviet Union behind the United States in the space race. General Nedelin decided to go and inspect the second stage leak up here on this platform. And as often happens, those of you who have worked in businesses of various kinds may know that when the boss goes to check on something, you have to go with him to look like you're interested. And so a whole bunch of people went with him. Unfortunately, when they were tinkering with the electrical panel, the second stage ignited on top of a fully fueled first stage, and the result was catastrophic. 92 people were killed, including some of the best physicists in the Soviet Union, and 49 others were injured. The largest impact crater confirmed to exist on the surface of the Earth exists in South Africa. It's the Verotafort Dome, and it is 190 miles in diameter and 2 billion years old. The Chicxulub crater, of course, that supposedly killed the dinosaurs, or did kill the dinosaurs, is only 93 miles across. There have been other larger craters suspected. There's a 300-mile wide crater that has been suspected based on some measurements in Antarctica. As of yet, that has never been fully confirmed. The largest radio telescope in the world. We have to move a little further away now to China. The Eye of the Heavens radio telescope went into operation in 2016 in Jinke village in Guizhou. It's 500 meters, half a kilometer across, 1,640 feet. The oldest astronomical observatory, where would we find that? Down under. This is the Wurdi Yuang site in Little River, Victoria in Australia. It's an Aboriginal site that was used for astronomical observations, particularly measuring the position of the sun and moon in various seasons. It's estimated to be 11,000 years old, very similar to Stonehenge in its utility. The first animal in space. Some of you may be old enough to remember this. The first animal in space was Laika, launched aboard Sputnik 2 on November 3rd, 1957. Regrettably, Laika became also the first spaceflight fatality, died 5 hours into the flight due to overheating, although it was never anticipated that they would be able to recover her. The first man and woman in space. These credits go again to the Soviet Union. Yuri Gagarin, of course, won orbit on April 12, 1961. Valentina Tereshkova in 1963, who flew 48 orbits. The first human spaceflight fatality was Vladimir Komarov on April 24, 1967. The Soyuz 1 space capsule had never flown before and was known to have a substantial number of structural flaws, so many that his good friend Yuri Gagarin begged to replace Komarov on the mission because he felt Komarov would be killed on the mission. Indeed, he was. The parachutes did not deploy, and Komarov was killed. The Soyuz, however, went on to be one of the most productive capsules in space history after some of these structural flaws were repaired. The most time spent in space goes to a Russian, Gennady Padalka, who has spent a total of 879 days in space over the space of 5 different flights. But what about the longest single space flight? That too goes to a Russian, Valery Polyakov, who went into space on one mission that lasted 441 days, covered over 7,000 orbits and 187 million miles. The most number of space flights of any human being, Jerry Ross and Frank Diaz, both of the United States. They flew 7 missions each, and that's currently the record. No one has done more. The human altitude record is still 249,205 miles. It was set on tax day in 1970 by Apollo 13. And the reason for this is that they did not drop into lunar orbit, but instead, of course, did a loop around the moon at much higher altitude without dropping into lunar orbit. And because of the moon's position, achieved a further distance from the center of the Earth of any human beings ever. The human speed record belongs to the astronauts aboard Apollo 10, Eugene Cernan, Tom Stafford, John Young, on May 26, 1969, as they returned to the Earth and just before arriving at Earth's atmosphere, achieved a speed of 24,846 miles per hour. The first unmanned landing on another world. We're back to a Soviet credit again. This was Luna 9, which landed on the moon on February 3rd, 1966, and took the first photograph from the surface. The first photo ever taken of Earth from the moon goes to the Lunar Orbiter 1 of NASA on August 23rd, 1966, and this is that image. This image, by the way, has been repaired from the original. The first man landing on another world, we all know that, Apollo 11, July 20th, 1969. By the way, that horizon out there is about 1.5 miles away. And the longest stay on another world, Apollo 17 astronauts spent 3 days and 3 hours on the moon. What about the highest known mountain in the universe? Well, we don't know about mountains outside the solar system, but we know a lot about the mountains within the solar system, thanks to all of our planetary missions. And the honor goes to no, not quite. It goes to Rhea Silvia on Vesta. The bulge you see here in the center stands 72,178 feet above the average radius of the asteroid. This is about 100 meters higher than the height of Olympus Mons on Mars. Now, the indication in the feet here is a little different. This slide was a little outdated, but it's still got the record. The first unmanned landing on another planet occurred when Ventura 7 touched down rather hard on Venus. Actually, the parachute shrouds melted during the descent, and so the vehicle dropped in free fall and landed in the last few meters, hitting at about 37 miles per hour and tumbling over on its side somewhat. It lasted about 53 minutes and did measure the temperature at the surface at 887 degrees Fahrenheit and the pressure at about 90 Earth atmospheres. The largest known crevice anywhere in the universe, but in the solar system, is Valles Marineris, of course, 2,700 miles long. The fastest spacecraft, this honor goes to the Parker Solar Probe, which on September 27th of last year reached a speed of 289,927 miles per hour relative to the sun. It's thought that it will eventually achieve a speed of 450,000 miles per hour relative to the sun during some of its later orbits. The most distant unmanned landing belongs to the Huygens mission, part of the Cassini mission, of course. The Huygens lander touched down on January 14th, 2005, at a distance of 885 million miles from Earth, and took this image. The first asteroid landing. That record goes to the Near Shoemaker mission, which touched down on Eros on February 12th, 2001. At the time, it was 158 million miles away from the Earth. Here's an image from the surface. The first landing on a comet was the Rosetta mission and the Philae lander, which landed on Comet 67P Churyumov-Gerasimenko on November 12, 2014, at a distance of approximately 300 million miles from Earth. And here's a surface photograph taken by the Philae lander. The greatest known comet impact, we all know that too, the Shoemaker-Levy Impact G on July 18th, 1994. And to give you some idea of how large an impact that is that you're seeing there, let's imagine it on Earth. This would be equivalent to an explosion equal to 6 teratons of TNT equivalent force, or about 5 million Hiroshimas. The most active volcano in the solar system, not on Earth, it's Io's Pele, a constant eruptor out of an enormous lava pool. The plume here is about 190 miles tall. The largest natural satellite in the solar system, or anywhere for that matter, that we know of is Ganymede, Jupiter's moon, almost as large as Mars and definitely larger than Mercury. It's 3,267 miles in diameter, and the Japanese have done some research on Ganymede and have looked at some of the circular furrows on the world and have determined that it also houses the largest known impact structure in the solar system. This structure is actually 4,836 miles in diameter, which is greater than the diameter of Ganymede itself, because these circular furrows extend even beyond the horizons that you see here. It's a global system of furrows, and it's estimated that the impactor was something in the vicinity of 50 kilometers in diameter. The largest known storm is not the Great Red Spot, but was the Great Springtime Storm, which was seen on Saturn from December 2010 to August 2011. This storm covered 1.5 billion square miles and was approximately 9,000 miles wide and 186,000 miles long, nearly circumnavigating the entire planet, as seen here. The storm is larger than the Earth by a factor of 8 times the area of the Earth's surface. The tallest known cliff known to exist, Verona Rupes, on the Uranian moon Miranda. It is 63,000 feet tall. It's on a very small world, however, and so if you jumped off the top, you'd have a very long, fun ride to the bottom. But you wouldn't like the landing. You'd still hit at 124 miles per hour after your 12-minute fall. Not recommended. The furthest man-made object from Earth, Voyager 1, at a distance of approximately 14 billion miles now. That's 1/2000th of a light year. It's taken 43 years to get there. But even at that speed and accomplishing that kind of distance, if it were headed toward Alpha Centauri, which it is not, it would still take 76,000 years to get there. Unfortunately, Voyager is expected to lose power in 2025. However, they've said this before, but have still been able to receive trillionth of a watt receptions from Voyager 1. It did substantial research as it plunged past the sun's heliopause and into interstellar space beyond. And so it's been a very significant mission indeed, and it's done far more than it was expected to. The most distant photo of Earth is something that was contributed also by Voyager 1. This image taken in 1990 from a distance of 3.7 billion miles. That's further than Neptune. The nearest star to the sun, of course, we all know, is Proxima Centauri. How many of you can pick it out in this photograph? You can do it. It's right there. It's hard to see without a telescope, and it's hard to find in a telescope unless you really know what you're looking for. It lies at a distance of about 25 trillion miles, 4.22 light years. That's about 8,330 times further than the planet Pluto. This is a star that's about 124,000 miles in diameter, so roughly 2 of them would fit between the Earth and the moon. What about the closest planet to the solar system, outside the solar system? Well, that too belongs to planets orbiting Proxima Centauri, seen here at this arrow. Here is a chart that shows the positions of Proxima Centauri b, which was the first planet discovered. It's represented by this little yellow circle here. It has an 11-day orbit around Proxima, but it lies in a zone that would be sufficient to maintain liquid water. A new planet called Proxima c has been detected at a much greater range and at a much colder location, and another Proxima d planet is suspected to exist well within the habitable zone in an area that would be too hot to sustain life. So possibly 3 planets in the vicinity of Proxima Centauri would qualify as the closest to the solar system. What about the furthest planet known to exist? Well, that record goes, and here's, by the way, a couple more on Proxima b, showing its size in relation to the Earth. This was the first planet found. And this is an artist's conception of a view from the surface of Proxima b, showing a sun that would look a bit larger than our sun. By the way, if you were at Proxima Centauri looking back at us, your sky would look pretty much the same. The sky would bear the same constellations. You'd see Cassiopeia here looking like an M, and it would have one extra star over here. That would be the sun, at approximately the magnitude that it would appear. Well, we asked about the furthest planet known to exist. That belongs to Sweeps 04 and Sweeps 011. These planets orbit a star that I'm not even going to attempt to name because it's got too many numbers in it. But the star lies at a distance of 27,710 light years toward the core of the Milky Way galaxy. It was found, the planets were found using the transit method, which is the most traditional and earliest method used to find exoplanets. This planet is estimated to have, Sweeps 04 is estimated to have a mass of 3.8 Jupiters. The closest supernova remnant, well, that is actually a local bubble that we're in, caused, it is now believed, by supernovas that erupted in subgroup B1 of the Pleiades moving group. So we're actually within a supernova remnant here on Earth. And here is a more detailed map of the local bubble in which we find ourselves that is believed to have been caused by this explosion. What about the most sun-like star that we've ever detected? That's easy. 18 Scorpii. Look at the similarities. The mass equal to that of the sun, luminosity equal to that of the sun, diameter equal to that of the sun, and temperature almost identical to the surface of the sun. The rotation periods are almost identical, the ages almost identical. So if you want to see what the sun looks like, just take a look at 18 Scorpii. It lies at a distance of 45 light years, so they could look back at us with the same telescope and see exactly what they look like from 45 light years away. No planets have been detected at 18 Scorpii as of yet. The largest known planet, and this is a tougher one. Actually, before I get to that, let me talk about apparent diameters of stars. Got ahead of myself, I apologize. The largest apparent sizes of the disks of stars seen from Earth, many people think it's Betelgeuse, but it's not. It's actually R Doradus, which subtends an angle of 57 one-thousandths of a second of arc seen from Earth. What you see here is the size of these stars, disks, compared to the apparent diameter of Pluto's disk as seen from Earth. The smallest planet that we've ever detected is Kepler 37b. We'll talk about Kepler again in a minute, but here it is. Kepler 37b is only slightly larger than our moon, but orbits its star, Kepler 37, and is, to this day, the smallest known planet in the universe that we have found. It has a 13-day orbit and a surface temperature of roughly 800 degrees Fahrenheit. Now, bear in mind that Pluto used to be the smallest known planet in the universe until we gave it up as a planet. So Kepler 37b has taken over the record as a result of that. And now the largest planet known to exist, it's estimated to be HD 100546b in Hercules. It orbits a star at about 320 light years distance. It has 6.9 times Jupiter's mass and a diameter of 607,000 miles. However, when planets get this large, they start becoming borderline brown dwarfs, and it's a very difficult question of when planetary status ends and star status begins. As planets get larger and larger, the heat in their cores rises high enough to begin low levels of fusion. And so this is still the planet that is regarded as a planet. It has roughly the density of balsa wood and could be a brown dwarf, but so far still holds the record as the largest known planet. What about the darkest known planet? Well, that turns out to be something called TRES 2b at a distance of 750 light years. It's orbiting a star called Kepler 1 in Draco. It has 1.27 times Jupiter's mass, and it reflects less than 1% of the light that strikes it. The temperature on the surface is about 2,000 degrees Fahrenheit, and this creates gaseous sodium at its surface, which is highly absorbent of light. And so it has such a tremendously low albedo as a result of this. The most symmetrical non-spherical object in the universe is generally regarded as the red rectangle in Monoceros at a distance of 2,300 light years. I think you can probably see why. The most planets around any star. Well, it turns out we used to have this record all by ourselves with 9 planets. But once again, when Pluto was demoted to dwarf planet status, Kepler 90 returned to first place tie with the solar system. Kepler 90 has 8 planets just like we do. Kepler 90 is a star, by the way, in the constellation of Draco. What about the coldest place in the universe? Not ever, but the coldest place when MIT is shut down from Ketterly's experiments. That would be the Boomerang Nebula in Centaurus. Temperature at its core is less than 1 degree Kelvin. It's because it is releasing gases at an extraordinary rate of 310,000 miles per hour. It lies at a distance of 5,000 light years from Earth. The hottest known star is seen right in the middle here, if you can see my cursor. This is Wolfray at 102 in Sagittarius. It lies at a distance of 9,400 light years. Has a radius of about 60% that of the sun, but a surface temperature not of 10,000 degrees like our sun, but rather 378,000 degrees. The fastest spinning pulsar known to exist. That would be PSR J1748-2446 in Sagittarius. It lies at a distance of 18,000 light years and spins at 716 revolutions per second. That's 24% the speed of light at the equator of the neutron star, or 156 million miles per hour. No star other than a neutron star could possibly rotate that fast without breaking apart. The largest known star is this star, Stevenson 218 in Scutum. It lies at a distance of 18,900 light years and has a diameter of 1.8 billion miles. That's roughly the same as Saturn's orbit. Here you see Stevenson 218 compared with the orbit of the Earth. The fastest moving star is F4714, which is seen here whirling around the supermassive black hole at the core of the Milky Way. It lies at a distance of 27,000 light years and is moving at 8% the speed of light relative to the black hole it's orbiting. The closest galaxy to the Milky Way is actually intertwined with it. It is the Canis Major galaxy, determined to exist by the 2-mass survey. Its core is 42,000 light years away from the core of our galaxy in the direction of Canis Major. It's consisting mostly of red giant stars that have been detected intertwining around the galaxy as a result of the 2-mass study. Here we have the fastest spinning star. This is VFTS 102 in the Large Magellanic Cloud. It lies at a distance of 164,000 light years and is depicted here in an artist's conception. It's spinning at a rate that results in a speed of rotation at its equator of 1 million miles per hour, nearly its breakup rate. That's 100 times faster rotation than our own sun. The largest known spiral galaxy would be the Condor Galaxy, NGC 6872 in Pavo. It's 522,000 light years from tip to tip and 212 million light years away. But what about the largest galaxy of any kind? That would be an elliptical galaxy in Virgo, known as IC 1101. It has approximately 100 trillion stars. That's about 500 times more stars than the Milky Way. And I've included an image of M81 in this image for comparison purposes. This galaxy is approximately 4 million light years wide. That would be larger than the distance between the Milky Way and Andromeda, and lies at a distance of 1 billion light years from Earth. The largest known structure in the universe is the huge, large quasar group. I'm not kidding, that's what it's called. It's abbreviated LQG. It's 73 quasars that stretch in a conical formation from Leo to Leo Minor. It's approximately 4 billion light years long. The hottest place in the universe now, when the Large Hadron Collider is not operating, is the galaxy cluster RxJ1347 in Virgo. A cloud of gas depicted here in the circle comes in at 540 million degrees Fahrenheit. This galaxy cluster lies at a distance of 5 billion light years. The most massive galaxy cluster known is in Phoenix. It involves galaxies with a total of approximately 3 quadrillion stars, lies at a distance of 7 billion light years, and is referred to as El Gordo because of its size. The largest known black hole in the universe, TON, T-O-N, 618 in Canis Major, lies at the center of a quasar. It is 240 billion miles in diameter. That's 1/25 of a light year, and has an equivalent mass of 66 billion solar masses. The brightest known object in the universe is seen here in a picture taken by my good friend Scott Connor with a 14-inch telescope in Evansville. It's quasar APM 082795255 in Lynx. It shines at magnitude plus 15.2, so it's readily accessible to Dobbs and to photography by amateurs. It has an equivalent brightness of 12 trillion suns and lies at a distance of 12 billion light years. That's looking back nearly as far as time could possibly allow light to reach us in the age of the universe. If this quasar were brought to Arcturus's distance from us, it would shine at magnitude minus 45. That would be 16 million times brighter than the sun if it were at Arcturus's distance from us. The furthest known galaxy from us is GNZ11. It lies at a light travel distance of 13.4 billion light years, which means that today it actually lies at 32 billion light years distance because of the expansion of the universe occurring during the time the light's been traveling to us. It's a protogalaxy, one of the first protogalaxies to form. It has only about 1 billion stars and is only about 600 light years in diameter. One of the primary reasons for the James Webb Telescope and its yellowish looking mirror is to detect protogalaxies in the very early universe that will all be heavily reddened because of the redshift that their light would have undergone in reaching us and in reaching the James Webb. But it will be studying galaxies just like this in the very early moments after the dark eras that followed transparency 380,000 years after the Big Bang. And the furthest thing ever imaged, of course, is the cosmic microwave background itself. The light travel time from the cosmic microwave background is the age of the universe, roughly 13.8 billion years. And so its distance is regarded as being, its co-moving distance is regarded as being 46 billion light years. It lies at what we call the cosmic particle horizon, or the cosmic horizon, which is the location today of the furthest things that we can see today. And so with that, we have seen the largest, the smallest, the fastest, the slowest, the firsts, and many other extremes. I want to thank you for the opportunity to join you tonight. It's been a real pleasure, and I was not able to keep the chat engaged during this. So if you have questions, I hope you will let me know, and I will stop sharing. There we go.
Hey, Chuck. I'm going to start out with one question.
Yes.
And that is Eye of the Heavens in China.
Yes.
Now, is that bigger than Arecibo in Puerto Rico?
Yeah. Oh, yes.
Oh, it is. Okay. Because
Oh, yeah.
so this isn't a matter of the largest in operation, because unfortunately.
No, it had beaten out Arecibo.
Okay, very
Yeah.
good. Reza, do we have any questions in the chat box?
Yeah, actually, Chuck, that was a great presentation. And it's like each object you mentioned brings out a lot of questions with it. So because of that,
some of which I may not be able to answer. It's hard enough to keep up with these records as they change. Every time I give this program, 4 or 5 of these slides have to be replaced. So I'll do the best I can, but go ahead.
And well, yeah, I was going to say, because there's so many questions, perhaps not everybody's going to ask them. So
sure,
we got a couple of questions here. So first of all, there's a question about the impact crater in South Africa. Let me see if I can pronounce it correctly. Is it Verderfort? Impact crater?
Yes, Verderfort.
So is that somebody's asking if that caused the mass extinction we know on Earth?
It isn't tied with one. However, the one that is suspected in Antarctica is suspected as being possibly involved with an extinction of 300 million years ago. So that's why they're still investigating that. The one in Antarctica may prove to be real. It was detected by satellites, but it hasn't been confirmed yet.
Okay, thank you.
Mm-hmm.
Now, somebody else is asking for what about the most water in a planet or dwarf planet or asteroid? Do you have a record for most amount of water in, some moons of Jupiter? We know that they have subsurface oceans and stuff. So do you have the record with an object which has the most amount of water in it?
Yes, I do. You remember that quasar I showed you at the end, the APM quasar, 12 trillion light years away, 12 billion light years away in lengths? That is the largest known repository of water in the universe. I know that sounds weird, but that is in fact the largest known repository of water based on its spectral studies of that quasar. It's some amazing amount. I don't remember the exact number. 12,000 times the volume of water on Earth, something like that involved. So that would be the answer.
Okay, but given its size, is that too disperse of water, or is that, how condensed would that be?
It's just water. The radiation from the quasar is passing through fields that are yielding a lot of indications of water in the galaxy that it lies at the center of, this quasar. Obviously, the quasar itself doesn't have the water, but the surrounding galaxy does. Okay,
and the next question is about, what about the highest density object? Would that be black holes, or what's close to that?
I mean, it would have to be a black hole. The singularity of a black hole would be off the charts. Really the densest thing you can imagine, short of a black hole, would be a neutron star. It's hard to pack anything more tightly than neutrons on neutrons. I mean, you're packing nucleic material together with no interatomic space at all.
Excellent, thank you. And now next question is about, how do they measure temperature of a galaxy?
I'm sorry, you cut out on me just for a second.
How the temperature of a galaxy is measured.
Well, I don't know that they measure temperatures of galaxies. Most of the information I gave you before was temperatures of stars. And the exact method for doing that, I'm not sure. It's obviously a combination of spectral analysis and understanding the anticipated size of the star based on objects moving around it, the mass of the star rather, not the size.
Okay, thank you. And now talking about exoplanets and their discoveries, as far as I know, there are like three major methods to discover one. The transit method, there's the wiggle that they create, and there's one other method I can't recall right now. How did they discover the exoplanets around Centauri? And what is the orientation there? Are they like on site or?
I don't know the answer to that. I would have to look that up. I think that would be readily found even on Wikipedia, frankly. The third method that you're mentioning is gravitational lensing, which has been used. And that's why we've been able to determine exoplanets existing at distances like 27,000 light years in the core of the galaxy. In fact, we had at our convention in Titusville, we had a talk by someone who was actually doing this really distant exoplanet work using that method. I just, off the top of my head, I don't know the orientation of the planets or the method used for that particular one. There are a lot of exoplanets, and to understand, how each one was determined, that would be take a while. So.
Excellent, thank you. Okay, so actually this covers the questions that we've received so far. We're gonna hang out a few more seconds for people to type in their new questions. And let me open up to the panelists if they have any other questions. Keith,
let me mention to Keith, Keith, the Arecibo radio telescope is 305 meters in width, and this is 500, so it's considerably larger.
Okay.
Now, there are radio telescopes that have resolution that might be greater because, like the Very Large Array, and there's a large array down in Chile that are expanded out over a longer distance than 500 meters.
Oh, very good. So in the beginning, when I was introducing you, Chuck, I got so wrapped up in the energy, I forgot to mention that joining us tonight is our Vice President of Programs, David Contreras, who is awesomely busy in the biomedical industry.
No, we met and you mentioned him. Yeah,
I did mention him?
Mm-hmm.
Oh, I forgot that I mentioned him. Well, David, I'm mentioning you again. No, to the audience. We mentioned.
Oh, I'm sorry. Yeah.
No, that's okay. That's okay. So, David, I'm so glad that you could make it. Do you have any questions? Unmute. Mute.
You spoke about the fastest craft, and was I led to believe it was the fastest speed that a human had traveled? And it was like 8,000.
The fastest that humans have traveled, David, was the Apollo 10 return to Earth. They nearly reached 25,000 miles per hour. The fastest that any spacecraft, unmanned, has gone so far is the Parker Solar Probe at about, I think it was 248,000 miles per hour relative to the sun.
So let me ask you this. In the Apollo, you may or may not be aware of this, but were there any anything show up on these people that were in that craft that showed some sort of change in their biological structure?
I'm sure there were some effects. Obviously, one of the primary concerns for all of these missions was cosmic ray, the effect of cosmic rays on human physiology. John Glenn, you may or may not recall, when he did his 3 orbits back in 1962 or 62, I guess it was, remembered seeing flashes of light in his eyes that were thought to be cosmic rays actually impacting the retinas of his eyes. So the cosmic ray impacts are a very significant factor. In fact, they increase the rate of cancer even in people who fly at high altitude a lot. Small amount of increased risk, but cosmic rays are high energy nuclei, protons, alpha particle nuclei, basically, that are moving at tremendous speeds. And if they pass through cells, they do tremendous damage that can lead to cancers later on. And the rate of cancer among astronauts, American astronauts, is higher than the average population. Now, whether, and of course, we all know that prolonged weightlessness has very significant effects, for at least temporary effects on people. But part of the reason we send people up into space for long periods of time is to find out, you know, what the effects are going to be and whether they can be reversed. But I don't know specifically, you know, what exams they received when they came back and what findings were found and whether they were permanent, but I'm sure there were some.
I'm sure I can find them if I dig, you know. I appreciate it. Thank you.
Mm-hmm.
Quick little bit of math, Chuck. I love to do this. I've got my calculator with me. Apollo at 25,000 miles per hour. Divide that by 3,600, 6.9 miles per second. Now, the spacecraft that you mentioned that was doing 250,000 miles per hour, that's 70 miles per second. That's fast. So anybody out there that wants to do their own little, oh, how many miles a second is that? You know, that's the distance from me to Moore Park College in the blink of an eye. And I'm living in Camarillo.
Yeah. It's fast.
Yes, yes, very fast.
But still not fast enough for interstellar travel.
No, well, we had the Orion project for that. Got any thoughts on Orion?
I just don't think that, I mean, technically, just applying simple relativity to the problem, if you could accelerate a rocket at 1G for a year, just the same acceleration you feel sitting in your chair, and drift for maybe 24 years, and then turn your rocket around and decelerate for a year, within that period of time, which a crew could survive, you could travel 35 million light years. From Earth, it would appear to take 35 million light years. So returning home, you would return home to 70 million light years later. But in order to do this, and I remember reading a time life study on this one time, or report on this one time, that you would need 250 pounds of fuel for every pound of spacecraft in order to sustain these two 1G burns. If you hit even sand grains going at that speed, you'd be destroyed by them. The spacecraft would. And when you came to a stop, even if you were lucky enough to actually end up in the middle of the galaxy you were heading for, the odds are you'd be 2 light years from the nearest object of interest of any kind, a star, whatever, and traveling at ordinary speeds over, you know, to 2 light years would be impossible also. So there are daunting engineering challenges, keeping crews alive for that long, avoiding brains. You'd have to collect fuel on the way with a scoop of some kind, interstellar hydrogen, and hope there was enough of it, because you couldn't take that much fuel with you from the surface. It's really an incredibly daunting task to imagine traveling to another star. However, you know, as one who once predicted in 1964 that the Beatles would never be successful in the United States, I'm not going to say that it can't be done. Perhaps it can.
Did you really predict that?
I did that. And I also said that the digital cameras would never replace film. So don't ask me for stock tips.
You know, I won't. So don't buy Bitcoin, huh?
Yeah, exactly.
Yeah. Okay. Looks like, did any more questions come in, Ray?
Yes, we have actually a few more. So somebody's inquiring again about the closest galaxy. So it's in general understanding that's Andromeda, but you mentioned it's a galaxy within our galaxy. Can you talk more about that?
Yeah, it's simply an older galaxy that was apparently absorbed by the Milky Way at some point in the past. And it was detected because of the movement and the nature of the stars. It's mostly red giant stars. It was an older galaxy. And these stars are looping around in a pattern that is inconsistent with their having formed in the Milky Way. And so it is thought to be a galaxy with which, a small galaxy with which we merged. Andromeda is certainly not the closest galaxy, even if you exclude that, though. I mean, the Magellanic Clouds are much closer. We have some dwarf galaxies that are closer to us than Andromeda as well. Andromeda, though, is certainly the closest major galaxy to us.
Excellent. Now we have a couple of questions about your presentation. Have you compiled the list into a website somewhere that we can access?
I have not. And I think in order to keep it up to date, I'd have to review it every week. These things, in doing this program, which is the second time I've done it in a month, I've had to change 5 slides already. That's how fast some of these records change as new discoveries are made. But I have not. So hopefully the YouTube will suffice for now.
However, if you do want to see this presentation, it's recorded on our YouTube channel as we speak, and I'm monitoring it. We've got 7 people watching. Within a week, that will be about 90 people will have watched it. So if you know somebody that missed it and wants to see it, or if you want to see it again, just log on to our YouTube channel and we'll be there. Just search Ventura County Astronomical Society on YouTube and you can watch it again. Chuck, this has been wonderful. Thank you. Reza, any more questions?
Well, yeah, 2 more actually.
Great.
So
I'm not going to close out just yet then. Just giving a plug for our YouTube channel.
So have you compiled, do you have all this information in SI units too?
Do I have this information?
In SI units, like kilometers and...
Oh, yeah, of course. I always debate with myself whether to use metric, because metric would be the appropriate thing to do in professional astronomy, certainly. But I find that audiences, somehow, most audiences are just more comfortable with English measurements, so I use those. But I can easily transform them. And I may do another taping of this with pure metric.
Excellent, thank you. And the last question here is that you mentioned our solar system is within a supernova remnant. And somebody's asking about all the elements or material that this supernova are made of.
Well, that material lies in what's called the fluff around the edge of the bubble. And if you remember that one slide I showed you that looked like a map that had the kind of a yellow outline around the outside of it, that area is where the material from these early supernova explosions is left. It's basically cleared out the area in between. So we're in that bubble now. And this isn't something that you can look out into space and see, you know, a bright wall. It's just gas that's known to exist there. And we are actually, the sun is embedded along with Alpha Centauri and Sirius and other Vega and other nearby stars in an area called local fluff, which is just some extra gas in our particular region left over from it. Now, previously, it was thought that the supernova remnant that we were in was called Geminga, which was a supernova that erupted, I think, 300 light years away. And only recent research is suggesting that the remnant we're in, it was actually caused by that B1 subgroup of the Pleiades moving group. Now, the Pleiades themselves are young stars, but there were older stars associated with the moving group out of which they formed. The gas out of which they formed had some older stars associated with it that exploded at some point in the past. More than one, apparently.
Excellent, thank you very much. This brings us to the end of the questions. Keith, do you have any final remarks?
Actually, Chuck, I know that the Astronomical League has recently celebrated its 75th anniversary. We are currently celebrating our 50th anniversary. We're glad to be members of your society. Is there anything that you would like to say about the Astronomical League while we have you with us?
Well, I wouldn't mind. The league is currently at a record size right now. We've reached 18,500 members in 304 societies around the country, and we have over 500 at-large members in clubs that are not associated with the league or where people, can't be close enough to a club to join. Our observing programs have gone through the roof. We have over 80 of them now. The RASC, by comparison, has 7. And it's just something that we have taken to a new level with our master progressions. We have master progressions for telescopic observing, for binocular observing, and now we have master progressions for imaging. These master progressions require completion of various numbers of programs of specific types, and by pursuing those programs in a certain way, such as imaging, which we find it really stimulates people's interest in pursuing these programs. And the more they get into them, the more excited they get about doing them. I have spent 70 all-nighters in the last 2.5 years at my dark sky site, 72 miles from my home, pursuing these programs. And during COVID, I've done most of this alone, and I'm so mission-oriented when I go, I don't even notice that I'm alone. It's just exciting to work on that. We have certainly, we're in the process now of spending a great deal of money on a complete website overhaul. We're not happy with our website. It's created problems and it doesn't look good. And so we're hiring a professional to completely redo the website. Our reflector is expanding by 4 more pages because it's very popular. It's a place where people can be recognized for observing awards or club awards that they receive, or regional awards, where people can submit articles or photographs to appear in Reflector from just members submitting stuff. This is why the league exists. The reason we charge such low dues. It's basically $5 a member for club members and $40 for at-large membership. The reason we don't charge 100 like the RASC is because they're really a professional amateur organization like the AAS if we didn't have an astronomical league. But we're about amateurs. We're for them and about them and recognize them. And I'm running now as vice president, as I did back in the 90s, 10 major award programs for the league, including our youth awards, which have major telescope prizes, cash prizes that are, I think we have at least 4 awards that are over $1,000 for writing, for photography, astrophotography, and 2 major awards for service, thanks to the support of the Horkheimer Charitable Fund. We have created a new award for astrophotography that'll be sponsored by the Explore Scientific, and we're about to announce that. And we have created already the Williamina Fleming Imaging Award for women who are members of the league who compete. We want to recognize women's accomplishments without necessarily putting them in competition with some of these 20-year world experts in astrophotography, because we want to encourage them to develop those skills. And this seemed like a great idea. So we are really flourishing right now. We're doing very well. COVID has not slowed us down. We're doing, I'm co-chairing with Terry Mann, who's also a past president of the league, the Alcon virtual convention that will be held from August 19th through 21st. This will be afternoon and evening sessions with major speakers, recognition of all of our award winners from 2020 and 2021. I'm sorry to go on so long in answering your question, but
please go ahead.
We're having an exciting time, and we're looking forward to getting back to a live convention at Albuquerque next year. And we just hope COVID will go away and David Contreras can get it under control by then for us. And I too appreciate what he does, because I know from other friends of mine in the healthcare industry what a tough time it's been.
Yes, Chuck, again, thank you for your service. I mentioned to you earlier that my dad was in the Air Force also. Yeah. So you and he would share that in common. He's passed away since. But I'd like to thank you for being here. We will stay close. I will monitor the changes in your website. I actually do have a certificate from the Astronomical League, but that was granted to me from the previous Alcor representative because of my work as the publicity director here, getting the word out.
I see.
No, I am working on an observing program, but I kind of lost touch with that because of COVID.
Sure.
I'm going to get back into it. You've inspired me. And it has been wonderful to have you with us tonight. I wish we could hear everybody applauding your talk. It was great.
The pleasure has been all mine, Keith. Thank you, and Reza and David, and all of you out there. I really appreciate the invitation. I hope you'll have me back sometime.
Okay, one last thing. As you celebrate 75 years and we celebrate 50 years, I'd like to let Orange County astronomers and Ventura County Astronomical Society remind them that in the beginning, we did our observing in the Thatcher Observatory up in Ojai. Well, since we moved away and went to Moore Park College, Thatcher Observatory fell into disuse and was even being used as a dormitory for some of the teachers. Next month in May, our speaker will be Dr. John Swift, who will talk about how he brought that back into a top-notch observatory at the Thatcher School. He was even featured on PBS in some programs. Really looking forward to his talk. Some history about the Thatcher Observatory, our old stomping grounds. So with that, Chuck Allen from the Astronomical League, thank you very much. Reza from Mission Control and the Orange County Astronomers. Orange County Astronomers, thank you. David Contreras, Vice President of Programs for Ventura County Astronomical Society, and to all of the astronomers with us and not watching us, thank you, and literally a good night.
Thank you very much, Keith. Let me mention everybody that all the attendees can help us make these meetings better by taking a few minutes to fill out a survey that should be already open in your browsers. And again, thanks everybody for attending. With this, I wish you great times ahead and see you all next month.